So,
oh, I see the record button.
Yeah, now I see the button.
Yeah.
Okay. Good. So the recording thingy is still showing me a spinning wheel, so I guess it hasn't started yet. Just waiting for it. Yes, okay, we are live. All right, so welcome everybody to the Dutch Clojure Meetup number 129, which means 129 consecutive months of Clojure Meetups in the Netherlands, even though now that we're going, online, that's harder to claim probably, but I'm gonna go ahead and claim it nonetheless. So almost 130 consecutive months of Clojure Meetups in the Netherlands. And tonight we have a full agenda. Actually, I'm super lazy and not even try to compose an interesting program for you guys because you are able to come up with interesting topic on the spot. But this time I did my homeworks and we have two talks. I saw both of our speakers have joined already. The first one is gonna be Lucio, who is dialing in from Italy, as you mentioned before. And he's gonna talk about a library built for ClojureScript forms. But I think Lucio is much more able to actually, explain everything about the project and himself by himself. So I'm gonna give the stage to Lucio. Go ahead.
Hi everyone. First of all, thanks for inviting me to this Dutch Clojure Meetup. It's a pleasure to be presenting here today. And before getting started with the talk, let me just quickly introduce myself. And actually, I'm gonna share my screen as well. Here we are. Can you all see it?
Yes.
Yeah. Nice. So my name is Lucio D'Alessandro. I have been working for Juxt for the last couple of years. As we said earlier, I'm from Italy, and I've had the chance to work on a couple of greenfield projects that really pushed me to understand how important code reusability is, especially because when you have to start from scratch every time, then you try to optimize what you can. And, if you can speed up the process, of course, you welcome tools that allow for that. And also my projects heavily focused on gathering user data through forms in the UI. So I had to deal a lot with forms. And that's why basically after a couple of failed attempts, I was able to put together this library called Fork that helps you with forms in your ClojureScript front-end application. So yeah, the name of the talk is Let's Take Back Control because of the way the API is designed, because it's really not intrusive and lets you manage all the UI. And what I'm giving you is basically just handlers to avoid writing boilerplate code. And so the talk will focus on 4 parts. First, we will go quickly through an introduction to forms so that everybody is on the same page. Then we will talk about why fork can be useful in your project. And then we will have some fun with the REPL. And then we will have a round of questions and answers that I will be happy to answer for you. So yeah, let's get started. What is a form in ClojureScript? This is a very basic form component. And to understand this, if you know hiccup and reagent, then it's going to be very easy to follow through. And yeah, we have 3 inputs: email, password, and repeat password. And that's what the output looks like here. And yeah, it's all pretty and everything, but not really useful if you don't have a submit button. And by the way, for the sake of this presentation, I'm not using any CSS class so that you can really focus on what matters. Although on the right side here, as you can see, it's styled. So there's a bit extra code, but it's all about styling. And so, yeah, I just left it out for the sake of the talk. So let's add a submit button. We basically have an on-submit handler here, and we're just alerting the string submitted. And we added this button here at the bottom. As simple as that. So if we move on, now we click. Well, yeah, we also have a required key to add just a little bit of validation so that, you know, we want our fields to be just, you know, full. And there you go. Now, as you can see, we are submitting the form. But what happens if you need more complex validation? For example, you know, matching this password with the confirmed password, because as of now, you know, we can just submit them. We don't have a way to make sure that the two passwords match. We need to have controlled inputs, which means that we have to manage all the form state ourselves. And we do this by using this handle change function, which is very straightforward. We basically pass the event of the component, of the HTML component, and then also the state that is just a random in reagent. And we get the name out of the state, out of the event, sorry. We get the value out of the same event, and then we simply associate in the state the name and value, as simple as that. And we need to add to our components a couple of keys, being on change, as you see, where we pass our function that we just wrote, and also the value, which is this helper, just a way of easily getting out of the state the value. And like this, we can wire up our handle change with the components. And if we scroll down, we can see the way it performs. And by the way, here I'm also printing the state, so you see live what happens. Basically, at each key press, we are storing the value in the state and reading it back with the value key here. As simple as that. Yeah. And whenever, well, yeah, okay. Whenever we submit now, instead of printing, just submitting, I'm actually printing the values, as you can see, email, password, and repeat password. Okay, cool. So let's move on. Now let's actually write some validation for the two passwords. So we can do it at each render. So we have this validate function, which takes the values and just, you know, threads an empty map. And if the password is not equal to repeat password, we associate to the map this error, passwords don't match. Very straightforward. And yeah, as simple as that. And here we just added a bit of logic to say that if the errors are empty, then we show the values in the alert. Otherwise, we return the errors just to make sure that everything works. So in here, we have our email as usual. Now, when I hit a key in this password field, we will see that the errors will be populated because they won't match anymore. There you go. And so to have them match again, I have to copy and paste this password in this field. There you go. Now they're empty. And when I submit, I'm getting the values again. But if they don't match, I see that the errors are there. And I'm just printing the errors in this alert. So, but what about the user experience now, right? Because here we know we have errors, but we don't show the user any error until like they submit. We're just showing them in an alert. So in order to improve the user experience, we want to take advantage of handle blur, which is a helper that is dispatched every time the input loses focus. So every time you change input, this function will be dispatched, and then we can do logic to improve the user experience. So here, basically, we are putting the name of the input, being email, password, or confirm password. When the input is left, we're basically just putting that into this key name touched. It's a set, so it will have unique keys. And also, we added some email validation and also a minimum requirement for the password. But, you know, it's just, this is completely up to you. I just did this because, you know, wanted to add also some extra validation for the email. And to wire it up, we need to add this onBlur key to our components and pass the handle blur callback, the function that we just wrote. And then also we want to leverage this touched variable that we have in here. And basically, by reading from the state what's been touched, we make sure that we can display the errors after we leave the input field. And if you look at this render error function, basically what this is doing is that if the input has been touched and the errors are in the state, then we show this div with the error, the related error of the input. And so, yeah, if we try that. And by the way, if you see here, the errors are already in the state because, of course, the password, the validation wants the password to have a minimum of 8 characters and to have at least a letter and a number. And the email cannot be empty, right? But we're not showing them just because none of the inputs have been touched at this point. So if I, for example, click in here and then leave the input, now email can't be empty. The error is showing because the email has been added to the touched field, and now even the password. So yeah, this is a nice way of showing the errors basically live as they go, but not to be too intrusive, because we don't want to have all the errors showing to the user before even they type anything. So we wait for the user to leave the input, and then we show the error. And yeah, that's all I've been adding here. So yeah, now the email has to have a dot something to be valid, and then the password, it has to have 8 charts and at least one number and one alphabet, one letter of the alphabet, and that's it. Now we can submit again. So yeah, you know, it starts getting a bit, how do you say, a bit verbose. There's, you know, a lot of functions here. And this is like still pretty basic. So what's missing, for example? When you submit the inputs, I'm refreshing so we have a clear state. So when submitting, the inputs are not being touched. So I don't know any error at the moment if I submit. And that's one thing, for example. Then we don't have any code to prevent multiple submissions. If, for example, the server code takes, I don't know, like half a second for the round trip or even less, then you might spam the submit button 4 or 5 times. And then, you know, you're sending 3, 4, 5 requests that you don't want to be sending to the server. Then we don't have any way to set programmatically any of the input. Like, you know, if you want to set email every time somebody touches a button or like on click or, you know, on some other components, we don't have a way to do that. There are other edge cases about other components like checkboxes, drop downs, and, you know, we didn't even mention those. We don't have a way to perform server-side validation on the go. For example, if you are signing up, you want to make sure that the user is not choosing an email that has already been used to sign up. So you know, you might want to do that kind of validation on the fly before even submitting. And then, yeah, all the code related to, you know, dynamic inputs, field arrays, we have nothing like this at this moment, right? And it's already a lot of code that we wrote. So let's try to use fork. Oops, let me go full screen again. Right. So let's try and let's see how fork can help us. And before we go to the fork implementation, just let me say that fork focuses, basically lets you focus on the UI rather than the logic, because all it gives you is a bunch of handlers to basically manage all that logic that we just wrote ourselves from scratch. So you avoid the boilerplate code, and you have full control of your components. If you need any custom behavior or anything at all, you can easily just add it in without, you know, having any drawbacks from that perspective. And it's very fast in that it's just reagent and ClojureScript functions. There's no overhead in learning the API. It's not a DSL built on top. Like the API doesn't look at all like a DSL, but it's just, as you can see, a map of functions. So by using fork, we have basically just this page here, and the entry point is this form function, and the full namespace is fork.reagent because, you know, we are just using reagent. But if you want to use reframe, you can do fork.reframe/form, and, you know, it's available also in reframe. And it takes 2 parameters, this form component. The first one is a configuration map, where we pass the validate function, which looks just like the one that we wrote, so no difference whatsoever. An on-submit key for the logic that we want to do on submit. And at this stage, we are still just showing an alert for simplicity. And also we are writing prevent default true, because we don't want to submit to the server automatically when we submit the form. We want to first, you know, make sure that there's no errors, and then maybe we submit to the server. And yeah, the second argument is a function that you provide, and it's basically a reagent component. And this component is called from fork with one argument, which is a map. And from this map, you can destructure all these keys, values, touched, errors, handle change, handle blur. And these keys are basically what what fork is made for. You will use all these keys and you don't have to write any boilerplate around that. But if you need any custom behavior, you can still just do it separately and just discard those keys. So yeah, basically we use handle change, handle blur, and the names are very intuitive. Like you don't have to understand what where handle change go. Of course, it's the handler for the onChange callback, and yeah, it's pretty much the same component. And yeah, let's just give it a go. This is what we have. We have values, which is an empty map, and touched, which is the set that we wrote before. We have the errors down here, and so yeah, we can write our email, our password, and something here. You see we have the error again because they don't match. So let me just get rid of the error. And then, yeah. So one thing that fork already gives you for free is that if you submit without with errors, then it basically touches all the inputs. You don't see it here because it's basically when you submit, all the inputs will be automatically touched, so I don't have to store them in the state because I know that one submission has already gone through, so all the errors must be displayed. And yeah, also the submit button is disabled because as you can see here, if errors is, I'm saying is not empty, and I have attempted more than one submission, then I'm going to disable the button. That's what it's doing. So I can't even basically submit, not even with enter. And right, let's move on. Let's try to add a more real behavior. At least let's try to fake it, because now we're just showing an alert. But let's actually write a submit form where we use this set submitting, which is a fork helper. And it's basically telling us that the form is being submitted. And then I'm basically just faking an HTTP request with this set timeout function. And I'm dispatching this function after 2 seconds. And what I'm doing is simply setting submitting to false. But at least we can see what happens in the UI while this is, faking the HTTP request. So first of all, again, let me try to submit, and I have my errors, attempted submissions one. So now let me populate the fields here. Is it 8? Probably it's not. Yeah, it is. Oops. No, I can't copy and paste, of course, from the password. Okay. So now when I submit, it's spinning. And then I have this global helper, which is setting submitting to true when I'm submitting. And what's nice is that you cannot spam the submit button. You see, if you see the attempted submissions will increase as I go, as I click. And also same thing from the input, you cannot spam it because this key is preventing the form from being submitted many times. And yeah, and this is basically all built in. So again, you don't have to worry about it. Now let's add, for example, another couple of components. Actually, let's just add here, it's just a select component so that, we see what happens when we have like a drop down, for example. So we're adding this line to the validation, basically making sure it's not empty, and this select component to basically right below the confirm password. And yeah, it's just a select. We give it a name. Then the values, again, value status, making sure they match, on change, handle change, on blur, handle blur. And then this is like a placeholder, choose one. It's not an option, actually, it's just used as a placeholder. And then we have our 3 options, being married, single, and prefer not to say. And that's what it looks like. Well, if you use this code, it doesn't look like that. But again, I'm styling it under the hood so that it looks a bit better in the UI, but the functionality doesn't change at all. So as you can see, the status can't be empty messages in the errors because we haven't chosen one yet. So if I submit now, I see the error here. But if I click and select anything, then it goes away because now in the state, we have status single. And yeah, that's just, like adding an extra component and wiring it up with fork. So let's continue. So remember that case where I said that we want to make sure that if a new user is signing up, they are signing up with an email that is not stored already in our database, right? So there's this helper called send server request. And again, to get it out of fork, you just destructure it along with all the other keys. With this, you can send requests to the server pretty handily. And there's a debounce option. So if it doesn't happen at each key press, and you can do it on change or on blur. In this instance, I'm doing it on change, and I'm debouncing it by half a second. So if I type 20 keys per per second, then I'm just going to dispatch 2 requests, not to overload the server. Then so yeah, this function, we still want to have our handle change logic in here. So that's why we use a do, because we still want to set the value in the state, but also we do a second side effect, which is send server request here. So it takes a map. We need a name, because this is used for the internal logic to store some stuff in the state. We need so if we want to have our up-to-date value, we can use this fork helper and pass just the event to get the most up-to-date value in our callback function. Then we debounce it. This is completely optional. You can also use throttle, and they're mutually exclusive. Then set waiting true. This is a key that allows us to prevent the form from being submitted while we are waiting for this HTTP request to return. So if we are dispatching the request and it hasn't returned yet, we cannot submit the form. That's what this is doing here, and it's optional. And then a clean on refetch to make sure that every time we send a new request from this input, from send server request, we clear the current state, so that every time it's a new, again, a new request with no leftover state around. And then we pass this function, HTTP email check, which is basically this. And again, I'm faking it because I'm just wrapping it in a timeout. But basically what fork gives you is a map with these keys: state, path, values, dirty, errors, and touched. And you can make use of all of them. And for the sake of the example, I'm making sure that email doesn't have any client-side error first. And if it doesn't, then I am making the HTTP request. And in the request, I'm basically saying that bar@foo.com is taken, a taken email. So if that's the case, that they are the same, the email that the user provides is already in the database, being far@foo.com, then I am setting in the state this error, being email already exists. And in both cases, though, I'm setting waiting to false, because I'm basically telling fork that the HTTP request has returned to the client, and so we can proceed with submission, or we can move on basically. So then, how am I showing the error? It's I've wrote an or here. The first when is just saying if we have a client-side error, show it. Nothing more than that, just like we had earlier. And then here we are saying that if there's a server error, show it in the UI. You can write this in any ways. I'm not saying this is the best way to do it, but just to see how you can basically use those helpers to do anything you want, really. So now let's see how it works. So let me type anything in the email input. And as you can see, there's a server key added to this global. And by the way, anything under fork region global, which is a reserved keyword, is anything that has to do with the external world. So it's not really related to our form, but for example, in this case, we made an HTTP request. So of course, some state keys are stored in this under this key, because it deals with the outside world as well. So basically, there's a waiting false, and we are attaching it to the specific email input here. So yeah, let me first write a valid email here. So right here, I'm submitting, and oh, by the way, for the validation, yeah, it's not complaining anymore about the validation, because I'm just making sure that the email is not empty. That's the only check I'm doing. So yeah, that's why it's not complaining about the .com anymore, just to make it even easier. So let's try to actually write the taken email, because now it is allowing me to submit. You see, attempted submission 3, successful submissions 3. Now it's gonna do 4, because this email is basically valid. It's not already stored in our database, in our fake HTTP code. One thing to notice, if I click and try to submit, it's not submitting, as you can see, because it's still waiting for the server to return. It's waiting a second, in this case, for it to return. Then after this key becomes false, then I can submit again. So you see, while it's true, I cannot submit, then it turns false, and I can submit. So let's use the bar at foo.com. Oh, now it's telling me email already exists, and I cannot submit because there's an error. So yeah, and you see it takes 0.5 seconds. That's why the error doesn't show immediately, because it's debounced. So yeah, that's why it doesn't show right away. But yeah. Basically with this helper, you write your own HTTP handler, and again, you get all these nice keys that you can use just, to help you out along the way, so that you don't have to write boilerplate logic. You just focus on the business code that you need to write for your use cases. So this is very, straightforward. It's not a heavy one. So yeah, you can use keywords, because as of now, all the input names were strings. But one of the latest releases, with one of the latest releases, I also included keywords. So as you can see, you can have also namespace keywords. The only trick is to get advantage of this normalized name. So instead of just writing the keyword or the namespace keyword as a name value for your input, you pass it to this function, and it just has to basically do some, not some magic, but the idea is that if you use a namespace keyword, HTML will drop completely the namespace, and so you're just left with the right part of, like in this case, account name. If you were to pass this to without normalized key, HTML will give you back just name, which is not what we want. Well, with normalized key, with normalized name, I'm making sure that I'm saving the string in the right format, so that then I can read it back with the namespace keyword, and nothing is changed. So yeah, if you look at the state here, we have email, and the value changes like that. And for account name, same thing. We read it back just like we used to with the namespace key. And if I submit, I get email as a keyword and account name as a namespace keyword. Yeah. So how to link fork to external components? Because one thing is to write all the components yourself, but sometimes you have React components or other people's components, and there's a way. It's actually pretty straightforward to wire it up to fork. And this is an example with the React date picker. I just picked a random date picker. And the functionality is this one. This is all managed by the library. And everything is stored in fork still. I called the input single date picker, and it's storing the moment object, basically. That's what it's storing. And how do we do that? I also added this input just, to keep another component that uses fork natively, which is this input right here. Then for this React date single date picker, I choose a name being single date picker in this case, and then I pass down to the component all these helpers coming from fork, which I named props. And so what do? We use this syntax. This is a reagent syntax to use React components. So just basically calling the React component name and passing all the props. And by the way, you can find these on the GitHub page of the library that you're using. So for this date picker, you wanted a date key, display format, and then on focus change. I mean, these are all, they all depend on the library you're using. So the way we wire it up is by taking advantage of set values, which is, again, a built-in function you can find from fork, and it's in the props. And with this, it basically just takes a map of a key and a value. And basically, the key is the single date picker key that I'm passing down. And the value is whatever value this on-date change callback will get back. And in this case, it's an object moment, as we can see. Then to show and close the pop-up, we also need to deal with this focus key and on focus change, these two keys. And in this instance, we are manually swapping into the state because you can get it from the prop still, the fork state where I'm storing everything, like this state, this map, it's an atom. So by getting it back, you can associate a focus key, which is a key that I chose to add to the state myself, which is this one here. And I basically take out of this event, the onFocus change event, the focused, it's basically an object coming from JavaScript, and I basically just take out the value which is either true or false or nil. And I just store that in the state and get it out in here with just, by dereferencing the state atom. And so, yeah, just, with a couple of lines, we basically wired up a React component and it's working. And again, you can run validation on it because it's stored in the state. So all the validation and everything will be connected. And yeah, when you save, when you submit, it will be stored as, whatever format your React component is using. And yeah, by the way, yeah, it's React dates. That's the library that I'm using in the example. It's written here. So now let's have some fun with the REPL and let's try to use field arrays. I mean, hopefully everything will go smooth because, when you do these things live, it's always a bit of a, gamble. But yeah. So actually, let me bring this here. Let me move this away. Okay.
Sorry, can you make the fonts on the editor a bit bigger? Thanks.
Yeah. Does it work?
I think so.
So let me just make sure that we are live. Yes, okay, we are live. So the field array allows us to have a number of, so let's say that we have a form and we don't know how many inputs we need beforehand, because we can have like a number of like customers, clients, anything we need. So with field array, we have a way of dynamically keep adding inputs to our form. And we can do that by using a fork component called field array, like that, which takes, again, two variables. And this is just like our form component up here. So the first one is just some config things. It takes the props coming from the first function here. And then the second one, it's a name, because where do we want to store these values? We can choose, and we can say in a field array. So that we are storing everything in there. And then the second value is a function, which we call field array function. And we have to define this outside. We cannot use an anonymous function because otherwise we have issues with reagent re-rendering our component. So it has to be its own defined function. We cannot use an anonymous function, just that. But besides that, yeah, all the rest, yeah, it's pretty straightforward. So the first one is props, and I'm using the syntax because I'm not using it for now. And then we can, the structure, it's going to be field array / keys, and they come from fork. And we have field, again, handle_change, handle_blur, and yeah, remove, insert. Let's use dots for now. So actually, this is fields. All right. So first of all, we use map index. Actually, yeah, let's use map index to loop over any eventual input we might have later. We loop over the fields, and then we have the index here as first argument, and then we have the field here. So then in here, we can, actually, I'm going to grab an input that's here so that I don't have to write all this HTML stuff. And it's basically just an input. We have a label called, let's say, name. And then for the input, we will have a name being, let's have our handle_change. And in this instance of the field array, we need to pass it the event and also the index, like that. Then same thing for handle_blur, besides that it's on change, sorry for that. And then on blur, handle_blur. And okay, then I want to wrap this in another component because I want to make sure that if fields is empty, because in the beginning we have 0 fields, we have nothing. I want to show an add button so that we can actually add. I can do button. I'm going to use this class, and on click, I'm just going to add with the insert function. I'm going to add a, say, I don't know, name. Actually, yeah, let's call this name. Forgot to add that in. And let me initiate it to be to, like, I don't know, placeholder or something. This is going to happen on click. And actually, hold on, I'm forgetting something here because I need to use field for something. I'm going to cheat a bit here. So, right, that's what I needed field from. Okay. Back to us here. The name is basically stored in the field, so we need to get it out from there. Yeah. And I think actually that's already enough. Let's keep this a unique key. So React doesn't complain. And now let's try to see if we wired everything up properly. Right, we forgot to give the button a name. That's why we don't see anything. Let's call it add person. All right, so if I click add person, oh, right, this is something, actually, I'm glad it happened, because what happened is that the form got submitted, and that's because the button by default is of type submit. So it's important to set the button type to button. Otherwise, we submit the form. If it's implicit, you know, it just gets the type submit automatically. So now if I add a person, there you go, I'm adding a name here, and I keep adding, you know, like that. It's all stored in a field array key inside a vector. Now, we can also get advantage of this remove key here, and we want to put it within this function. So let's just add a button that just, you know, removes the specific input. So again, type button. This is important not to submit. Oops. And then we have the on-click handler. And in this case, it's going to be remove, and you just press the index. As simple as that. Just with the index. So if I refresh, now it's going to clear the state. I'm adding, yeah, let's also give a name to the button. Always forget that. Remove field, remove person. Okay. So if I am, you know, writing here, remove this person, then that person, oops, what happened? I might have done something wrong in this component. You know what? Let me just use this. Let's see. Well, yeah, I called it finished, right? So yeah, the only difference is that I just added, you know, some values when I'm setting the value here, and you know the style is slightly different, but basically, yeah, you can basically add and delete components like that. I might have like just, you know, missed something, you know, trivial in here that I'm not considering, but basically, yeah, that's the functionality of the field array. Like that. And also in this instance, you see, like I added some logic so that if the count is not greater than 1, basically I'm not dispatching, because if you want to have for sure at least one of them, then you can prevent this from being, you know, deleted. It's just, you know, normal logic that you will read yourself. And yeah, for the rest, it's pretty much the same. There's nothing more to add on this. Yeah, add new person, the insert function with the name and last name. When I add a new person, and then when you remove it, actually, this one actually removes the correct one. I don't know why that one wasn't removing the correct one, but I've done something wrong on the way. So yeah, cool. So let's continue. Let me get back to this now. Yeah, so what's next for fork? So first, there will be another namespace to support React hooks, so you can use it with the other libraries that are not, reagent-based. Then also, it's good to add some manipulation of the values so that whenever you leave the inputs, it's going to run that validation. And for example, if you need to do any formatting, or if you want to cast a number to a string or stuff like that, you can do it on Blur, a bit like Excel works, just to, to make an example. Basically, you want the $sign. So whenever you edit, it's going to be an input. And then whenever you leave the input, you're going to have the $sign there, kind of like that behavior. And then also a docs, because now it's just like a README on GitHub. So I'm planning on actually, having a website with some nice docs and examples, so that it's just easy to, look at what you can do with fork, copy and paste code, and it's, just easier to, to use. And yeah, that's pretty much it. If you guys have any question, I'm happy to answer them.
Yeah. I actually do have the first question. So is this library already used in, let's say, production somewhere?
Yeah, it's used in 3-4 production projects. Yeah, I started developing this because I had a requirement in a project, and I really wanted to use a form library with these kinds of features that I took, by the way, from Formic, which is a library in JS land. So when I looked at that API, I was like, this is really sweet. So I basically brought the API over because I thought we need something like this in ClojureScript. So basically, yeah, I drafted it, and then I started using it in production after basically a month that I started writing it. And then, the more I go on with projects and the more I use it in production, and I keep, refining it. But yeah, it's used in production. Yeah.
Thanks. Okay, I'm going to shoot another question because, I was waiting for somebody else to not allow me to hog the internet space. But anyways, do you have examples maybe on how to integrate this with Reframe and the events and handlers and stuff?
Yeah, actually, on the README, actually the full README is based on Reframe, because again, the APIs are exactly the same, so there's no difference. And basically, if you want to keep up with Reframe, the README, just use a Reframe everywhere. If, for example, I show, yeah, there you go. This is basically your own submit function will take a Reframe event, and then in your Reframe event, you will get your props here, just like you would get any arguments in any frame event, and then you manipulate one thing is that all the fork global helpers, which are, set submitting, set waiting, set error, all of those just manipulate data. So you can use it in like in set an atom in reagent, or here in just, like in Reframe directly by, updating the DB. So they are composable. You don't have to worry about any side effect because none of them perform side effects. So yeah.
Cool, thanks.
Yeah. I think I'll stop presenting.
Any further question for Lucio? 3, 2, 1. Okay.
This is Tom. This is Tom. Sorry, this is
yeah.
Tom. I have a question. Sorry, it took me a couple of seconds to unmute. So is this something that could be used on the server side too? So if you're doing server-side rendering, you do batch imports of data via on the command line, or you have fixture data or something like that, and You want to be able to return to the client the same set of errors, but because of a server validation, because something got triggered on the server side.
Yeah, no, right. The thing is, if you're using reframe or reagent server side, then like you can use this pretty, easily. You can use, the good thing is that the validation is just like a function that you write yourself at the moment. So it's basically, it could be anything. So if you happen to be on the server, your validation, can involve, server-side code, and you can check, I guess like a database or, anything like that. Just, be careful because that validation, well, yeah, the thing is that it's happening on each re-render, right? So when you do it server-side, you just need to be careful about that, like the way you orchestrate it, but it's definitely possible to use this code, yeah, server-side. I haven't seen any example or anybody doing it. And actually, I might put it up an example if somebody wants to, but yeah, it's definitely possible.
Okay, great, thanks.
Yeah.
All right, so any further questions for Lucio? Maybe yes, maybe no. Let's say no. Okay, so thank you very much, Lucio, for your presentation. Much appreciated. I'm probably gonna go ahead and try to use your library in my project. So awesome. Okay, we have a second presentation on the line. We have Vlad already connected. I see him here. I might say that we might want to have a 5 minutes break before the second presentation, or go straight into this one. What do you guys prefer? Write on the chat if you are, let's say, pro break or pro continue, if you don't want to shout. Okay, so I just skimming, yeah, okay. No one wants, well, no one, that's not true. The majority doesn't want to make a break, so we can just go ahead and continue with the second talk in our agenda, which is still about UIs, but in a completely different context. Now we're talking about desktop applications written in Clojure, leveraging JavaFX somehow. But again, as with Lucio, I think Vlad is much more capable of describing both the project and himself by himself. So Vlad, the stage is yours.
Hello. I'm gonna start presenting. And I can't present.
You cannot present?
Yeah.
Permissions?
Okay. Do you see it now?
Yes, it's happening.
Okay. So you're seeing the window, I guess. Okay. Do you see the slides now? Yes? No?
Yes.
Hello?
Yes. Okay. I can see the slides. Yes. Sorry.
Great. Hi everyone. Thanks for inviting me. My name is Vlad, and I'm a citizen of Russia and a resident of Sweden. And I'm gonna talk about UI, but this time about the desktop, and specifically about the cljfx library, which I wrote. But first, we're gonna start with the problem. And sometimes people want to write complex stateful applications that need to manage a lot of state and dependencies between different parts of state. For example, game engines. So here's a default. It's a game engine that I had pleasure working on, and it's written in Clojure. well, more specifically, the editor for that, the part that is running on the user devices is actually written in C++. But the editor is like a.
Sorry, Vlad, if I may interrupt you, I'm not sure if you are presenting the slides or moving ahead of the slides. As somebody else on the chat mentioned, we can only see the title slide.
That's. What about now?
I can see the other slides now. Yes.
Yeah, for some reason, Firefox only allows me to share one window, and then I start presenting, it shows it in another one.
Yeah.
Okay, so we'll look at that. So.
Thanks.
Yeah, default editor. In 2015, on ClojureConch, people. Here you can see Ragnar Svensson. It's one of the authors of default, talking about the rewrite of Java-based editor for the game engine to a Clojure-based, because the editor is huge and complex, and they have state bugs, and it's getting complex. And when we are talking about state and complexity, Clojure is like a natural fit for these kinds of problems to solve. So they rewrote it in Clojure. They made this wonderful dependency graph that is updatable leaf when you use the editor, but they stopped at that. The UI for that editor is still a mutable soup of side effects. And I thought coming to the job that, and I was coming to the job from the world of React and Reframe and Reagent, where there everything was neat and functional. So I felt that I need to have. I felt that like for such a complex application that handle the state beautifully, like the game state beautifully, there should also be a library to deal with the UI in the same pure way. And then another problem, which is I think I'm passionate about, is a place for tooling. I think a great place for tooling is a process in which we are doing the development. For example, as you might know, there are two libraries, Criterium and CLJ Async Profiler. Criterium is a library for micro benchmarking. You feed it an expression at it, and it runs it a bunch of times, and it waits for JIT warm up, and then it does the actual measurements. And this is useful for micro benchmarking the code, and it's available in the REPL. And then there is a CLJ Async Profiler, which is also a tool available in the REPL that you can use to profile like the whole application and build the flame graphs to see where the most of the time is spent. But since all of those are in the same REPL, you can combine them together, and you can make Profiler profile the process of benchmarking. So you can have a flame graphs of your particular piece of code that you're interested in optimizing. And this is, I think, a great power that is available to us for the REPL, and because both of those tools exist in the process. Another thing that is very useful is data inspection. Currently, we have a REPL with the p part being just a print, which is just a string representation of object you're looking at. And what I'm about to show you is a different kind of REPL that you are already, all of you have available at your fingertips, that allows inspection of every object and in the VM. And this is browser console. Here you can evaluate a code and get the result back. But this is not just a string. This is like an object that you can inspect and store as a variable available for further inspections. And this is done for JavaScript, for web debugging, where REPL-driven development isn't really a thing that is so very useful. And here in Clojure land, we don't have this, even though we live in our REPLs every day. So I think this could be improved. And that's another reason why I wrote this library. And yeah, let's see that we currently have in Clojure specifically. There is a namespace clojure.inspector. How many of you know that it exists? It's a built-in in the Clojure standard library. What it does is it allows to. Sorry. Okay, I'm continue. What it does is it allows you to feed it some data and it will show a window displaying it. But unlike browser inspector, you can't really do anything with results with this window. You can just look at it and like you can store it in the variable or def it somewhere to inspect in any other way. So I think this is pretty far from perfect, and it's slowly getting better. For example, here is this tool from Cognitect, which is called Rebel, and this is a JavaFX application, like a pure JavaFX one, that provides a way to give you a visual REPL with different data visualizations. But it suffers the same problem, is that on the right part where you see your evaluation results, these are still just leaf nodes that you can just look at, and this is it. This is all you can do. So this is my current project that I am exploring is a reveal, which is a read while visualize loop for Clojure, which is closer to browser REPLs, which is closer to browser inspectors, that allows you to inspect any value and for every visualization to drill down and go deeper and see what else is there. So, for example, here you can see that I'm looking at a Java bean of some object, and I can select a part of it and bring up a context menu and inspect it further. And none of that would be possible if I wouldn't made cljfx, which is a React-like wrapper of JavaFX for Clojure specifically. But before we start diving into it, I'm going to address an elephant in the room when it comes to developing an application for the desktop, and which is Electron, and using like the browser to do desktop development, which is a very good choice. But it isn't always the best choice. For example, if we are talking about language semantics, I think Clojure wins over ClojureScript. For example, you don't have to define macros in different compilation phase. You can just you can mix macros and uses of these macros in the same place, because Clojure allows it, or concurrency primitives that are built in, that are absent in JavaScript virtual machines because of their semantics. And it has better performance and better ecosystem in terms of maturity. At least Maven doesn't seem to break every once in a while, unlike NPM. But there are, of course, still bad parts. For example, the industry support is very low when we are talking about desktop development with JavaFX and cljfx, because JavaFX is developed by like a small team of developers at Oracle, and cljfx is maintained by this one guy. And typesetting, and this is actually a thing that web is very good at, and other desktop UI frameworks are usually much worse at. And by typesetting, I mean like the initial nature of the web being documents, where you can zoom in on anything. You can select all text like in the one action, or you can search on any text. In other UI frameworks, including JavaFX and cljfx, you have to do it manually, while in web you basically have it for free. Okay, so now I can start. In cljfx, components are described as maps. This is not a hiccup, and there are a couple of reasons for that. The first reason is that hiccup allows nesting anything in anything. Like you can nest every node, like every HTML element can have children. Well, almost any element. And hiccup supports that out of the box by allowing you to pass like more vectors after the first two arguments. While in JavaFX it isn't true. There are leaf nodes there. You can't pass really any children. And the other reason for me picking maps is that it is easier to create such descriptions programmatically. Try updating a prop on a hiccup component. You will have to look at the second element, check if it's a map. If it's not a map, that you need to create a map and put it as a second element, stuff like that. Here is just an assoc. And yeah, so here we have our description, and then it's time to create. So there is cljfx.api namespace, which is mainly used, and we have a function create component, which will, given a description, create a component, which is a sort of it contains a metadata about the current state of the component and the actual like object, like an instance of that component. And if we were to translate this code directly into using JavaFX, it would be pretty similar. But since we have descriptions is data, we can do much more than that. And this is, for example, changing it by just applying another description. So here we are advancing it to a new state. And you can see that the text of this text field changed, but those two components are sharing the same text field. So the first implication is that this diff process tries to be optimal, and the second implication is that there is a mutable state involved in these components. And In addition to that, JavaFX isn't thread safe, and because of that, this advanced component function isn't also thread safe. So this is unfortunate, but there are ways around it. I'm just showing you like the very basics of how things work. So if you are changing props, we are changing, like we are mutating our instance. If we are changing fx type, which is a special keyword that describes the type of our object, then we are creating a new object. We also support functions, not only keywords to describe components, but I guess if you're familiar with React or Regent, this shouldn't come to you as a surprise. It's pretty straightforward, I think. And finally, we are coming to renderer. So renderer is a function that you can fit component descriptions to, and it will perform all these creations and all this advancing to a new state for you. So you don't have to deal with this mutable and non-thread safe create and advance if you don't want to. This renderer function is thread safe. You can feed it a million descriptions per second, and it will still deduplicate them and run the UI at the 60 frames per second, because it manages all that stuff for you. So here, I think it's also a good place to give you a short intro to what is a JavaFX. Because on this slide you can see three main types of objects that are in a JavaFX. The first is a stage, and this is a JavaFX term for Windows, like the things in your operating system that might be showing. The second is a scene, which is a sort of a holder for your display graph, and it has information that is usually only a single information about the whole graph. Stuff like style sheet that is used, or camera that is looking at the scene. And finally, there are nodes, which are, I guess, if we're comparing it to the web, correspond to HTML text like div or EMG. And here is an example of the node is a text field. So we can feed descriptions to render, and it will do all the advancing for us. And you can like change the types of objects, and it will, well, like React, it will handle the whole diffing and updating process behind the scenes. And here we can have event handling, which is just functions that you specify as a props. And when we do typing, we also receiving these events. So now we want to have some state, and this is that's how it is done. You just put a different you use a regular atom. It's just a simple atom that you have in in Clojure, and on your event handler will just update that atom. And if you want to update the UI, you should just dereference that atom and feed this transform the description or the state in your application to a cljfx description and feed it into renderer. And that's basically it. And there are helpers in cljfx to aid with that. So first is the renderer middleware that allows you to transform to map state in your atom to cljfx description, which you can see here. And then here is a mount renderer function that literally just adds a watch to an atom and fits the new state renderer. So with that, we close the loop and have the whole reactive application that just that works on atoms. But there is more. These are like more advanced concepts, and that I introduced. Mostly, some of them were inspired by Reframe. For example, here you can see that you can use maps as event handlers, and when you create a renderer, you can specify a map event handler. So this is like a layer of interaction to make your events, to give your event definitions good equality semantics. Because if you are using anonymous functions, they will make the diffing process to update the actual handler every time the rendering is performed. So also inspired by Reframe, there are effects and co-effects which allow you to make even your event handlers pure. But these are all, unlike in Reframe, these are all opt-in. You don't have to use it if you don't want to. Another thing is that there is a lot of examples, and this is because cljfx is not the first data-driven functional React-like wrapper of JavaFX that exists. It's actually a second one. The first one is fnfx, and I was there are a couple of problems with it that made me so frustrated. I wrote a cljfx. The first one is that it's all macro based, so you can't really understand the source code at all, because it's macros generating macros, and then you're using it also by using macros. And the second problem with that was that there was no documentation, or there were like hardly any examples. So it was very hard to figure out what's going on. And I decided that I don't want it to be unapproachable. So I made a lot of examples, and I have very long README. But then there is more. There is a cljfx CSS. It's a library for doing styling in code. I think it's a very, very valuable way. It's very valuable to have a way to define your CSS in code, because not every styling information can be expressed in CSS. Sometimes you want to put your color on a thing that doesn't support styling, and like if you just use the CSS, you would have to duplicate your color definitions. Here we can have them all in the one place in code and use them both to creating CSS and to and in code. Here is an example of such thing. So as you can see, there is a scene definition, and in style sheets, I just specify an URL of previously defined style CSS, and at the same time, I'm using the colors from the same like the same source of truth to encode, because this thing can be configured in CSS. I think that's quite nice. There are more helpers. There are fx keys, which is a way to identify a component in list of components that is similar to React keys, that performs reordering instead of recreating nodes when they change their order in the display graph changes. There is packaging, and this is a pretty recent thing. It's hard. Well, it was hard to create desktop applications using Java, because you need to build a distribution that also includes a JVM, and also we have different operating systems, and every operating system has their own way to specify applications. Like on Linux, it's like deb files or RPM packages. On macOS, it's folders with a special conventions around naming, and on Windows it's exe files. And before Java 14, you have to build all of those yourself if you wanted to make your app available on major operating systems. But now you can do it with a tool that is built into a GTK, which is just gets your Uber jar and emits packages. There's even more advanced stuff that I'm not going to explain, but just to give an overview. But there are reframe-like subscriptions. There are like you can extend the meaning of what like how your description is like how its life cycle is managed. For example, by creating a different life cycles, which is a protocol that cljfx is based on. It's like a core of cljfx. So here you can see that you can, for example, have a lifecycle that allows you to just create your own objects, like using functions, or create custom properties that you can then use on the components that don't have those properties by default. So in summary, I think JVM is a good place, is a fitting like a target for writing desktop applications. Not for all cases, but for but there are such cases, such as big and stateful applications, or tooling for the JVM. And I think cljfx makes all of that easier by giving you a straightforward functional reactive semantics. And this is it. Thank you.
Thank you so much. Is there anybody with questions for Vlad?
Nope.
I actually, yeah, I have a question. Is there any, let's say, main major application that uses cljfx out there that you can look at?
Well, the first is that I know of is Default, which is a game editor for the game engine that I initially was one of the reasons why I wrote cljfx. I get a couple of questions from time to time from random people, so it is used by someone. And I'm using it to write reveal, which is a read while visualize loop that is that builds on cljfx and its semantics to give users like a way to not only have a great visual REPL, but being able to easily extend it. There was a request for demo. Do you want to see reveal?
That might be nice. Yeah.
I can show it real quick. Okay. Okay, I'll try sharing. Entire screen. Okay. I have it somewhere. So can you see the screen now, right?
Yeah.
Okay. Sorry. So here you can see my cursive window on the left and reveal on the right. This is sort of a custom output for Apple. But what is special about it is that it's not text, or it's not just a text. You can select everything and evaluate your coordinates, for example, increment something, or see this number as a Java bean and realize that it's long, and then maybe datafy this long and see its description. And if we are talking about reveal stuff, or cljfx stuff, is that it's extensible in a way that allows you to use those simple descriptions to create views that make sense for your domain. Here, here's an example that I was working on. Should I increase the font maybe?
Oh, that might help. Yeah.
Yeah. Enter. What? Oh my God! No, this is too big. Okay. So imagine that you're developing a server for a game that is a chess, like a multiplayer chess game where every player is a chess piece. On your server, you might have your state in this atom, like server state, that has rooms which are like currently active games, and their state, where you have coordinates of positions and the descriptions of your players. So what you have by default in reveal is that you can watch any atom, for example, for updates, and then you can change it to something else and see it updated. So here I closed a server room with ID 2, and you see that it disappeared. So like the first state was a map with 2 keys, and the second one is the map without the second key. And like this is built in, but this like when you're developing, that might not be the representation you want to look at. You might want to look at as a collection of boards, like a chessboards. So here you can use this cljfx descriptions to create your custom view for that. So here's this custom view boards. So yeah, on the left you see that these are descriptions that I was talking about earlier. Just maps, data that you can sample from code, and it's all explorable. Like you can select this chess piece and request a context menu on it. And just as before, when you were selecting like objects in the REPL output in the like a textual representation, you have the same power in your custom representation to explore this data. Like who is this knight? It's a Bob. So like this is your data that is also here, but in a way that might make more sense. And this is not static. It's listening to your server state item. For example, if you move the piece, it will instantly update, and you can see it leave. So this is sort of the thing you can build with cljfx. And yeah, okay, I guess does it count as a demo?
Absolutely. It's actually a very nice visualization tool. So yeah, thanks.
That was pretty cool.
Yeah, thanks. I'm about to release it. It's in early access, which means there are breaking changes from time to time here and there. But I'm currently in the process of writing like the proper documentation and doing a 1.0 release.
Cool. That's really impressive. It's really nice to see. You know, it felt like sort of a notebook kind of application, which you can have your custom renderer for data, and even though it's sort of a side output for your REPL, not necessarily a notebook. But yeah, that was nice.
Yeah. Yeah, it is like that. Reveal has charts built in, so if I guess there are some similarities with notebooks, because it like given your like map of numbers or like a list of numbers, it can build charts dynamically for you as well.
Cool. We have a question from the chat. So are you in cljfx? Are you doing the diff thingy that React does to know what to re-render?
Yes. Good question. Yes, I do pretty similar thing to what React does. So whenever there is a re-rendering that has to occur, I go through the whole tree of descriptions and check them. But in my non-scientific performance benchmarks, the bottleneck was always a JavaFX and like the updating like the actual DOM nodes, so to speak. So I guess the Clojure equality semantics really helps with that. So I haven't really had any performance problems with cljfx. that were caused by diffing. I had performance problems, but when I was trying to show a huge, like a huge graphs of nodes, and when you're starting to show like thousands of nodes, the JavaFX gets slow. It gets slow faster than the web, I think. But yeah, it's not something that is cljfx related, really.
I remember that I did try the default editor some time ago, and I remember it to be, let's say, slightly more complicated than TextEdit. It's a fairly extensive application. It didn't feel sloppy or slow, or you can go fairly far, I guess, without having to necessarily core into performance issues.
Yeah, but I should probably mention it that default isn't written in cljfx. Like it isn't rewritten into it, because the thing that was there when I joined it was working fine. We just like started integrating it in different pieces that make sense. So it's like currently it's a mishmash of just using JavaFX via interop and cljfx. And there are times where default can be very slow on some machines, and this has to do with the OpenGL. And the problem is that JavaFX doesn't expose any API to show, like, to just render stuff using the GPU. There are no such things, and like the workaround is to draw to the GPU of screen and then copy the results into an image that JavaFX can show, and this sometimes is very slow.
I see. Okay.
Any other questions?
You mentioned that JavaFX is not really much used. I tried to use it many years ago, and it was a fairly horrible development experience. I guess cljfx fixes good part of that, but would you regard the JavaFX as a like solid foundation on top of which to build your desktop application by now?
It's a very very good question, because like there are parts of JavaFX that are really solid, and stuff like text rendering or layout. But when it comes to components or like controls, like date pickers or charts, then it feels that it's a little bit buggy here and there. So yeah, JavaFX is still buggy.
Okay. And can you easily create your own components then?
Do you mean creating your own cljfx or JavaFX component?
Is there a difference, or?
Well, yes, a little bit, because cljfx is sort of a wrapper with semantics for how and when like it does mutations. So you're not really like building your custom nodes other than like combining them from other pieces. And this is mostly what I'm doing when I'm using cljfx. I'm using like a smaller, simple pieces that are in JavaFX that they are working well and combine them together into something bigger. So this kind of creating custom components using cljfx, which is basically just combining simpler components, is perfectly fine. But creating custom nodes, I don't really know how to do that. It's like there is a big there is a lot of mutable stuff underneath in JavaFX that I just mostly try to avoid as much as possible.
I see.
Yeah, but there are tools in cljfx that help with wrapping other JavaFX nodes to make them like usable from maps.
Yeah, I did a quick search on how to make a custom JavaFX component, and I'm seeing tons of XML, and I stopped there. Yeah. But I guess it's yeah. So what you say is that you need to create your own. If you want a custom date picker, then you need to shell into an actual custom JavaFX component. Then you can let's say display it through cljfx. That would be the flow.
Yeah, or I mean, yeah, or like there are like there are different nodes that you can combine together, like text fields, just boxes and pop-up windows that are shown on click, and with that you can build your own nodes without really going into JavaFX territory.
I see. Yeah.
Is
So
there some
yeah,
JavaFX you wish existed? Some JavaFX nodes. I haven't really felt the need for custom nodes much. So yeah, I guess I don't have any wishes for JavaFX. Why not Swing? Because it's discontinued. I think Oracle officially deprecated it, and JavaFX is currently the supported UI framework for desktop Java. And it shows, like when I was showing the slides, have you like, if you remember, there is a Clojure.inspector package that is like a built-in, and you could see that like it had like very huge window borders, but the content in it was very small, and that one is written in Swing, and it doesn't support high DPI screens, which are like more and more popular today. So I think like it's hard to pick Swing today. Yeah, HTML renderer, it actually exists in JavaFX. There is a way to embed a browser, so you can you can use cljfx to do web development as well.
okay. That makes me think like you can create your own, let's say, Electron with cljfx, and then run your ClojureScript UI inside of it.
Yeah. I'm not very proficient in the web stuff nowadays, but I know that the thing that JavaFX uses for displaying HTML, it isn't a Chrome, it's a WebKit.
Yeah.
So it's a I don't know what to do with this information, but I know it, and I hope you will find it interesting or useful, or good to know.
Yeah. It should be some sort of a guarantee that things should be not so broken, at least. So it should work.
Yeah.
Okay. Do we have any more questions? Two, one. Kirill, no?
No.
Okay. All right. So I guess that was it for tonight. That was the end of the second talk. Thank you very much, Vlad, for the presentation and for the tool.
Thanks
I
very much.
actually tried FNFX myself for a tiny application I needed to build, and I failed miserably. So I might try to succeed with cljfx. Let's see how that works. But that's interesting. All right. So I guess in the agenda we had yet another point, which is pretty much random stuff. If anybody wants to talk about anything, it's a good moment now to do that. Do we have any serendipitous topic we want to discuss?
Sorry for interrupting you, but I need to run.
Right.
Children, you know. So
Yeah.
thank you for talks and see you next time, guys. Thank you.
Thanks, Kirill. Bye.
Bye.
Yeah, likewise. I'm going to drop off too. I just want to thank both of the speakers for both presentations. They were awesome. Appreciate them taking the time to do that. Thanks a lot. And thanks for setting this up. Thanks for a great meeting, guys.
Cheers.
Ciao.
Yeah. See you next time. Bye. We're going to do the usual count of 3, 3, 2, 1. No further topics to discuss tonight. So that means we are at the end of the meetup number 129. Again, I also would like to send a big thank you to both speakers. It's always awesome to have a full agenda for the evening and not have to invent something on the spot, as I usually have, well, not usually recently, but as I usually had to do, at least in the past. So thank you very much, Lucio and Vlad, and I'm gonna welcome you guys next month for meetup number 130. Is a well-round number. We are gonna be there, and I will probably try to do something slightly different for the next meetup, because in the physical meetups we did many times the dojos that I feel like we should try to do again, even in this online setting. Let's see if how we are gonna deal with the pair programming in a conf call environment. That's gonna be interesting. So that's the plan for meetup 130 in October. And for now, thank you very much for joining, and enjoy the rest of your day, evening, afternoon. I have no idea where you're dialing from, so enjoy the rest of the time for today. See you guys. I'm gonna stop the recording now.
Thanks, Carlo.
Yeah. Bye-bye.
Thanks for hosting.
Bye.
Bye.
Carlo, maybe a live share in VS Code could help with interactive coding with several people.
That has the slight disadvantage of using VS Code.
Yes.
But yeah, it's in my intention is that we're going to do pair programming. So as soon as we form the pair, I'm gonna come prepared with a couple of tips how to deal with pair programming. But then every pair should be able to pick and choose whatever they want to do. I'm gonna experiment a little bit behind the scenes, and let's see if there's any Emacs trick to pull under your sleeve, so that you don't have to have a VS Code or to learn how to VS Code. Let's put it this way. Or you can use VS Code if you already know how to use it as well. That also works, of course.